Hello everyone, I am Swaraj and this is my project demonstration video. So this is my GitHub repository Swaraj836 and this is my project name as Chronos. So you can see the link Swaraj836 and Chronos. So what you have to do is to clone the repository, first go to code, select, copy this link. I am using IntelliJ IDE. You can use whatever you may like. New project from version control, which is Git. You can set a directory. I have set to downloads. You can paste the URL here. And once you will clone, it will get cloned in your downloads as I have done it already. So you can see in the downloads, you will see this folder Chronos. So you can open this in a new window. So I have opened this from the Chronos. You can like open downloads and you can select your project folder. It will come like this. So here is the readme step by step for installation and testing the project. So I have kept it as a Word file which I created myself and then pasted in the GitHub. As you can see in the GitHub too. You can see the readme for more detailed instructions. Okay, let's start. So first of all, we will start. Let me demonstrate my project. So first open a git bash. So we have opened a git bash. So go to the project directly. It's downloads. So in downloads, I have Chronos. So go for cd CHRONOS Chronos. So we are inside the Chronos. When you see my project structure, you can see API service, worker service, logs, infra, and inside infra, you can see the Docker Compose file. So first we'll use the list command to check if you're in the correct directory. So yes, we have API service, infra, log, scripts. Okay, so we will go inside infra. Okay, so here is the place where we will start our Docker. So here are some prerequisites. First, you have JDK 17 installed. You can see direct detailed instruction. You have to have installed Maven on your system. You should have Docker and Docker Compose, and Docker must be running. So when you run the Docker, this is a Docker desktop app. It should look like this. This is our infra. When we create it, will get play button. Okay. So let's first see the docker ps command. So when we paste it here, there are no containers running. So we want our containers to run docker compose d. So it will turn on all the containers. You can see infra, Kafka container, Grafana, FileBit, Kibana, Zookeeper, Postgres, Elasticsearch, Prometheus, and all those things are started. So inside my project, there are two modules. First is API service module, which code you can see Java code, all the controller, service, everything is here. And my second module is worker service. Source, main, Java, and all the codes are there. So here is a quick diagram of the sequence of the job creation. So user is here. This is the API service. So user will create an API using the API service. It will post a job. So Spring Boot will receive our job from the postman. Here we'll test the project from the postman. So the job is as soon as the API service receives this job, which is here. This is the API service. The job will be sent to DB for storage. From this DB, the scheduler, which we have cores will pick up the jobs from the DB and schedule it on the time. For example, it will schedule on maybe tomorrow or day after tomorrow, or maybe cron jobs for every minute or every 60 seconds for every 10 seconds. So scheduler will schedule the jobs and send to Kafka. Kafka is a message queue. It will send here in the topics, and topics will be consumed by the worker service. So worker service will do what? It will take the messages from the Kafka and it will execute the job. For example, perform HTTP request or something, fetch information from somewhere else. So this is the And once the task is complete, it will insert its completion into DB for the logs. And then we have successful mechanism and failure mechanism. So first, what we have to do, from the postman, user will send the job to API. Okay, so we have to start this API service, which will accept the jobs and send to the database, and from database scheduler will take it. Okay, so when we start the API service, we'll start a Spring Boot API service with the scheduler, which is Quartz. So let's see. So first we will use this command to build our API service jar file. So we paste it here, and as you see, this will so we have to come out of the infra directory. We have to come to the root directory to check. We have see ls, and again we have API service infra logs. Okay, so now we will run this command. So this will build the jar file. Okay, so you can see building API service snapshot, and the build is successful. It means this API service is ready, and now we have to run it. So run the command. We will execute this command, pasted the command and running. So as you can see, Spring is starting and it is generating the logs. Okay, so our app is running. How to see our app is running? So we have this health API in the postman chronos. So health check. So first we will hit the send button, and you can see the JSON status is up, components database component is up, this page is up. As you can see in the preview, the components are up. Okay, so list jobs. Okay, so this API list all the jobs. So when we send, so see, you can see this the content, there is empty content we have generated because we can see only 20 results. You see the preview, the content is empty for now because we have not created any jobs as of now. So till now we have in the terminal 1 we have started our API service. So now we'll test it. Okay, so we'll start a Kafka consumer inside the container. So we'll consume traces from the topic. Okay, so Kafka has topic. So what we will do, we will open another git bash terminal. So this is terminal number 2. We are inside download our project structure and inside the infra. So we will execute this command. So the consumes messages from your topic. So this will consume the messages from our topic. So check that Kafka is getting the messages in the topic. We'll run this command. So consumer client, consumer group ID console 6935. Okay. Chronos execute job. This is the topic name, leader not available. So let's start it once again. Sometimes it gives an error. So we'll run the command once again. So now we will wait. So today the date, system date is to 2025, 12th December, 13th of December. Right now this is 1347. This is the international time format, not Indian time. Okay, so we will fire a job. Okay, so this is the job. So this job, what it does, it will create an interval job. Type is interval, schedule expression after 10 seconds it will hit. Okay, okay, so we'll create this job. 201 job is created successfully. Success response code, the job ID is C1EB3. C1EB3. So when we see, so we can see C1EB3. See every 10 seconds this job is firing. So 2 times this job has been fired in 20 seconds, as you can see. And after 10 seconds, this job will get fired again. So this is the third 30 seconds, the third job is getting fired. Okay, this is successful. So it is working. Okay, so we can get job by ID. Okay, list all the jobs. So we have total one content. Okay, preview one job we have. So job ID is C1EB. C1EB interval. It is an interval of cron jobs at schedule expression 10 means every 10 seconds it will fire. Okay. So till now we have only 2 things till now here as so let's come back. So user via postman is sending jobs, is sending the database. Now database from the scheduler, which is Quartz, is getting jobs from the database and it is sending to Kafka. but Kafka is listening to scheduler, of course, okay. But now there is a worker service. So Kafka, there is no consumer for Kafka, okay. So now this worker service will execute the job. Actually, this will fire the jobs. For example, I have sent a job to open the web page. So this worker will consume the message from the topic of Kafka to itself, and it will execute the job, perform the job. You can see. So now we will activate the worker service. As you can see, this is the worker service here, right here. Okay, ignore this worker for now. This is the worker service. So how to start the worker service? So for that, we'll open another git bash terminal. Okay, DOWNLODS CD. So let's come back again. So till now, the user is sending the jobs via through the Postman API service is receiving the jobs and sending it to the DB, and Quartz is accepting the jobs from here and sending to the Kafka. Kafka topics are populated now. The worker service will consume from the Kafka topic. So let's get back. Okay, our terminal 3. So from the doc, from the readme file, you can see we'll open a third terminal we have opened, and then we will build the jar for the worker service. So this is the third terminal. We will paste our command and execute it. So it will build a jar. So building Chronos worker service. So build is success. So now we will run it. So the command to run our worker service, we will paste in the terminal and we will execute. So as you can see, this is Spring is starting and it is emitting the logs. Okay, this is it. So to test it, we will open a console. So to test this, we have to open a third terminal or a console. So we will open a fourth terminal. So we have our 4 terminal. We will go inside the infra folder, downloads Chronos infra. Okay, so we will execute this command. We will connect to Postgres inside our container. So this is the command to connect. So in our 4 terminal, we will paste this command and we will execute it. Okay, so there's a console is opened here. So inside the console, we will run this query inside the Postgres console. So we will paste this query of ours and then we'll hit enter. So see, there were earlier rows were there, earlier jobs. Okay, so let's see and our job. So job ID is C1EB3F. Okay, C1EB3F. So this is from my previous. Okay, this is from my previous run. Okay, so to see this in the real time, this is old data. We can see this is the old data which I ran today around 1924. So for having the real life data, we will execute this command watch 2. So it will auto refresh the query after every 2 seconds. So we'll paste the command here. So what it will do is it will every 2 seconds it will fetch it. Okay. So let's check our job ID C1EB3F. Okay, it will take some time. Okay, so you can see the job ID C1EB3. Okay, so we have only one jobs. Okay, so what is happening is these jobs are being triggered to the Kafka, and from Kafka it is fetched by the worker service. Okay, attempts mean it is taking 2 attempts. It took 3 attempts. Okay, and here see it started at this time and the end time is this attempt 111. Some jobs took third attempt, some took second attempt, some took only first attempt. Okay, as you can see here. Okay, to test it more, like we will create another job. Okay, so let's create another job. Okay, so for example, we'll create new job. Okay, so for this we will create every 5 seconds. Okay, every 5 seconds, and in the every 5 seconds we can say FIVE or 5 seconds. Okay, so we created this job. So the job ID is E22EB. E22EB Z201 created. Okay, so we can see here, see E22EB every 5 seconds is firing. See, C1EB is firing every 10 seconds. Okay, you can see C1EB is firing every 10 seconds, but E22B every 5 second, 5 second, 10 second, 5 second, 5 second, every 10 seconds. Okay, we can see. So for example, E22B 5 seconds, 5 seconds, 10 second, 5 second, again 5 seconds, so this is getting fired, and this is the 10 second, and we can see in our consumer it is consuming from the Kafka topic. So see E22EB. Okay, you can see the timestamp 1928 28. Okay, it is getting executed. See, okay, similarly if you want, I can create a job of every 30 seconds we can create, or maybe 20 seconds we can create, or we can create every 20 seconds. Okay, so every we can cite 20 seconds. Okay, so when we create this job 201, id is 458b f037. So let's test this. So 458b f037, 458b f037. Okay, so we have only one job because 20 seconds have not yet passed. Okay, 458b f30. Okay, after 20 seconds you can see here again. Okay, see there's a time limit is 20 seconds between these two interval, 45.8b, 45.8b. Okay, you can see it. And into E22B EB to 5 seconds, C1EB 10 seconds. And it is running. See, it is getting refreshed after every 2 seconds. Okay, so the job we created was 45 450 458BF. Okay, 458BF. You can see first attempt it got executed. Okay, so this is our service. So similarly, I have designed other APIs also. For example, if I want to delete or cancel the job, for example, I can cancel the job. So first list all the jobs. Let's see what all jobs we have created. Earlier there was only one job. So now when we create, so you can see the three jobs, preview three content, three jobs are there. So C1EB, let me expand it. Okay. So C1EB schedule expression 10 seconds. Okay. Interval job firing 10 seconds. E22EB after every 5 seconds, and this one is after every 20 seconds. So let's stop this this job. Okay. So we can see. So this job ID E22EB. E22EB is firing after every 5 seconds. So let's copy this job ID. Okay. We have copied this. Okay. And so let's find this job. Okay. So here is the environment. Okay. So job ID, job ID, and we have paste this ID. Okay. We close this environment. So this list job, you can see this will job ID will fetch from the environment. Okay. So E22 is job ID and username password for the security JWT authentication. We have created a default for now. Okay. So send. So there is one result. Okay. Preview is one. Okay. So this is the job ID. We have interval test every 5 seconds, interval scheduled. Okay. Now I want to delete this job. Okay. Or patch or cancel this job. So job ID we have the same, and it will delete the or cancel the job. So send. Let's say 200. Okay. So this owner ID is T22EB. Okay. Let's check. So see, now E22EB will not get fired. It was getting fired after every 5 seconds. Okay. But now you can see they have a 10-second pass. It is not fired yet. Okay. C1EB is getting fired. 45.8FB037 is getting fired. But E22B there is not getting fired. Okay. So before this, there is this E22B is getting fired. Okay. Here. But now you will not see. Only two jobs are getting fired. And let's check in our other terminal. We can see. So now, so it takes it will take some time to reflect here. Meantime, let's analyze the postman logs. Okay. So Type is okay. Attempts, 3 attempts are allowed. Status cancelled is here. Okay. So and we can similarly delete the job. Okay. And we can delete the job. 204 no contents. This job is related. Which job is related? You can see this E22 EB. Okay. So this is my API which is working. So it is taking in the real time. Okay. Similarly, we can get job execution history. Okay. So let's see. So this was the job which was getting fired every 5 seconds. Okay. Every 5 seconds it was getting fired. Okay. HTTP job executed with status 200, 200, 200 arguments, status code. Okay. So the job ID. Okay. So let's take the job after every 20 seconds. Okay. So this was the for the cron jobs. Okay. So for example, if we create a one-time job, okay, for example, a job is scheduled to be created to be executed after a day or after a week or maybe after 1 hour. Okay. So but we want to run it immediately. So that will come under the run now trigger. So and that usually what happens first, it is the job data is stored in database. It is fetched by the scheduler or the quars. It sends to Kafka, it will publish to Kafka, and then from Kafka the worker will consume. But in that case, the user will send the API to the API Spring Boot, and Spring Boot will directly publish to Kafka. No scheduler, because they no need of scheduler. Okay, because we have to run the job immediately, and this job will be consumed by be sent to publish to the Kafka, and from Kafka the worker will consume it, and it will execute and record to the DB. Okay, this is the my run now sequence, and the fourth diagram which I am shown here is about the failure and retries. So from the worker, if there will be unattempts allowed, for example in a job we gave 3 attempts. Okay, so after 3 attempts it will execute. If there are transient failures, so it will use the retry mechanism, and if there is a permanent failure maybe after 3 attempts, it will publish to the dead letter queue. Okay, in the Kafka, and it will uh, it will inform the scheduler accordingly. And finally, I have attached my entity relationship diagram, ER diagram. You can see users have these things. There are jobs, fields, and execution fields. And coming up with monitoring. So till now, the version of the code which I have uploaded till now is still here. Okay, so it has not yet having the logic of logging and monitoring, because I need some more time. But and the project which I am working on my system right now is a version where logging is introduced. Okay, so the logs will be generated in this logs folder. Okay, in the root folder there is logs folder. So here we can see the API logs timestamp. So this was the test message, hello Chronos test, hi message Swaraj, which I there, and it is being logged here. We can see the console, and that logs will be stashed via log stash in the file bit will send it to Elasticsearch, and Elasticsearch, from there we will fetch into our Kibana. This is the Kibana dashboard. So here the logs will come here. This is the view I have created. So here we will, so when we search our hello Chronos test message, the documents will come, and here we will fetch that documents, the logs here, and using these logs we can create our dashboard. Similarly, we'll create a Grafana dashboard, which I am still in progress. The work is in progress, which I have not uploaded in my GitHub as of now. Once that code is ready, I will push it to GitHub. That's it, my friends. And for scalability, the scalability is achieved through stateless service components that can be horizontally scaled based on workload demands. The message broker, which is Kafka, and the database forms the backbone of the system distributed processing model, enabling high throughput job handling without bottlenecks. Okay, so the Kafka is so we could have used only database. Okay, but we are using Kafka, which is a database which has high throughput. Okay, and so we are using a combination of both Kafka and traditional database, which is Postgres. So through this we can, if we have more loads, we have to scale horizontally. We will increase the number of topics in the Kafka. we can scale Kafka and we can scale a database. So through this, no matter how much load testing. So after this, I will also include load testing in my projects, which will be successful. So till now, this is my project. In this time, I only was able to create this much. So if get allowed more time, I can expand my project and can enhance it more. So thank you for watching patiently, and have a nice day and all the best to all of you. Thank you.